In 1848, a chemist of 25 looked into a microscope and discovered that molecules, like your hands, come in left and right. He proved it not with any grand apparatus, but with a pair of tweezers, sorting tiny crystals one by one. The clue came from wine. In the barrels, two acids form that had chemists baffled: tartaric acid and a rarer twin called racemic acid. And by every test, they were identical. The same atoms, the same formula, the same reactions. Yet shine a beam of polarized light through tartaric acid, and it twists the light's plane to one side. Through racemic acid, nothing at all. Two substances, the same in everything a chemist could measure, and yet one bent light and the other didn't. So here was the riddle. How can two substances made of exactly the same atoms differ in the way they touch light? Something about them had to differ, something no formula could capture. Pasteur crystallized a salt of the puzzling racemic acid and put its crystals under the microscope. Each one carried a tiny slanted facet, an asymmetry. And the crystals came in two kinds, not different shapes, but mirror images of one another, a left-handed form and a right-handed form, like a scatter of tiny gloves. So he did something almost absurdly patient. With a fine needle, under the lens, he sorted the crystals by hand, one at a time, into two piles, all the left-handed crystals here, all the right-handed there. Then he dissolved each pile on its own and sent polarized light through it. The right-handed crystals twisted the light to the right, exactly like natural tartaric acid. The left-handed crystals twisted it to the left by precisely the same amount. Pour the two together, and their opposite twists cancel, which is why racemic acid, all along, had seemed to do nothing. There was only one way to read this. The two acids are built from the very same atoms, but assembled into shapes that are mirror images, one the reflection of the other, and no more superimposable than your left hand on your right. The crystal's handedness was just the outward sign of a handedness in the molecule itself. Pasteur had found that molecules have a handedness, chirality, and with it, a whole new chemistry of shape. He couldn't yet say why. The picture of four bonds reaching out from a carbon atom, which explains it, was still 26 years away. But he had shown that a molecule's form, not only its ingredients, is part of what it is. Its beauty is what he read, and how. With a microscope, a pair of tweezers, and a beam of light, Pasteur reached the three-dimensional shape of a molecule far too small to ever see. And he glimpsed something stranger still, that life itself keeps to one hand. The molecules of living things are almost all single-handed. A lopsidedness, he suspected, might be the very signature of life. Two identical acids, told apart by a difference you could only hold in your hand. Beautiful experiments.